What's up, YouTubers? It's Miss Sorensen here with Video 1 Review. Let's get started. Okay, question 1. How many radians are in a circle? Hopefully we know the answer to that, and the answer is 2 pi. The question is why, however? Well, a unit circle has a radius of 1. So if we take the circumference of that with the formula 2 pi r and plug in 1, we can see that we get our correct answer of 2 pi. Now, how many radians are in 180 degrees? Well, if 360 degrees is equal to 2 pi, and I want to know what 180 degrees is, well, of course, I just half what I had before, and half of 2 pi is simply pi. All right, next question is what's sine of pi, cosine 0, and tangent of 0? To do this, we have to look at our unit circle, specifically the points on the axis, or the axes. This is the coordinate 1, 0. This is the coordinate 0, 1. This is the coordinate -1, 0, and this is the coordinate 0, -1. Now, the first coordinate is the cosine, so I'm going to go ahead and put a C next to the first coordinates there. And the second coordinate, you guessed it, is the sine. Now, I have to label what my radians are all the way around the unit circle. Here we have 0, 2 pi. Here we've got a half of pi, or pi over 2. Here we've got pi. Here we've got 3 pi over 2. All right, so now we're ready to answer these questions. What is sine of pi? Well, the answer to that is located right here because I'm at my pi and I go to my second coordinate. This is equal to 0. What's cosine of 0? I'm going to go right here because I've got 0 radians, and so that is going to be equal to 1. And tangent of 0, of course, we know tangent is equal to sine over cosine. So I'm going to go right here, okay, and I'm going to do sine over cosine. In this case, we've got 0 divided by 1. 0 divided by 1 is, of course, 0. All right. Next is our 45, 45, 90 triangle. And our two legs should be exactly the same. They should be equal. So for example, if I had 5 here, I would have 5 here as well. And then to get from our legs to our hypotenuse, we're going to multiply by root 2. In this case, we'll have 5 square root of 2. And you can use this picture right here to help you remember that. All right, filling in this table, we have 3 root 2, 9 root 2, 15 root 2, 18 root 2, 24 root 2, 25 root 2. All right, nailed it. Let's move on. The 30, 60, 90 triangle is just that. We've got 30 degrees and 60 degrees and 90 in our triangle. Notice how our hypotenuse, the side opposite our 90, is always twice as big as our short leg. Okay, so here's our hypotenuse, here's our short leg, and of course this would be our long leg. And you've got this picture right here to help you with that. So we always take our hypotenuse and we cut it in half to get to the short leg. So for example, if this was length 10, this would be length 5. Now how do I get from the short leg to the long leg? Well, you can see right here, it's telling you to multiply by root 3. And in this case, we're going to have 5 root 3. Let's go ahead and fill in the table now. 1, 2, 1 root 3, 2, 4, 2 root 3, 4, 8, 4 root 3, 5, 10, 5 root 3, 6, 12, 6 root 3, 5. Did I get that one right? No, I did not. Okay, this one's going to be a 10. Okay, and then this is going to be double that is going to be a 20. So just notice that to get from our short leg to our hypotenuse, we are multiplying all of these by 2. Okay, all these are being multiplied by 2 times 2 times 2 times 2. Then to get to our long leg right here, I'm going to take my short leg, in this case 4, and multiply it by root 3, and you get a 4 root 3. All right, moving forward. Let's review rationalizing the denominator. So let's say, for example, we have a problem like 8 divided by the square root of 2. Now, this isn't wrong per se, but it's really not proper mathematics. We don't want to leave a square root in the denominator. So what we're going to do is we're going to multiply by 1. But that 1 is going to look like square root of 2 divided by the square root of 2. So multiplying across here, I get 8 times the square root of 2 divided by square root of 2 times the square root of 2, which is, of course, the square root of 4. However, what is the square root of 4? Correctamungo, if you said it, it is 2. And now we've got an 8 divided by 2, and what is that simplified to? Okay, what is 8 divided by 2 simplified to? It simplifies to 4. So we're going to go ahead and write this as a 4 root 2. All right, moving forward. Review of sine, cosine, and tan. And if you have a hard time remembering this, remember so, ka, toa. Meaning sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I'm going to go ahead and do a quick example of that. Let's go ahead and do a 3, 4, 5 triangle. It's my favorite triangle. And let's go ahead and call this angle X. All right, if we've done that, we want to go ahead and label our sides. To do that, we, of course, go across from the 90. That's our hypotenuse. Go across from our angle. That's our opposite. And the remaining side is our adjacent. All right, so now let's go ahead and do this problem. What is sine of X? What is cosine of X? And what is tangent of X? Well, sine is opposite over hypotenuse, so I'm going to have 4 over 5. Cosine is adjacent over hypotenuse, so that's going to be 3 over 5. And tangent is opposite over adjacent, which is going to be 4 over 3. All right. Reciprocals. If you take the reciprocal of cosine, you get secant. Well, cosine is adjacent over hypotenuse, so secant of an angle is going to be the reciprocal of adjacent over hypotenuse, is going to be h over a. Cosecant is going to be the reciprocal of sine. Well, if sine is opposite over hypotenuse, then cosecant theta is going to be hypotenuse over opposite. Cotangent of an angle, cotangent theta, is the reciprocal of tangent. Tangent, of course, is opposite over adjacent, so we flip that and we get AO. All right, let's go ahead and go down here and do a few examples. Let's say I asked you for secant of C, sexy. Let's say I asked you for cosecant of C, and let's say I asked you for cotangent of C. So what you would do is circle your angle C. You would go across from that. That's your opposite. Go across from your 90. That's your hypotenuse. And your remaining side is your adjacent. All right, so secant is h over a, so that's going to be 25 over 7. Cosecant C is h over o, so that's 25 over 24. And cotangent of C is AO is going to be 7 over 24. Perfection. All right, next thing here is our trig table. And we're just going to go ahead and we're going to derive a few of these. And then I think after that, we'll just kind of move forward with this. All right, so here we're going to use what we learned about what we learned about special right triangles to fill out these pictures. So let's go ahead on this 30, 60, 90. Let's give our hypotenuse a 2. Now we know that we cut our hypotenuse in half, and that gives us 1. That gives me 1 for our short leg. And then this would be a 1 times square root of 3, or just square root of 3. Okay. Now over here, let's go ahead and write these two lengths as 1 times 1, and now this is going to be the square root of 2. All right, so sine of 30 degrees is going to be opposite over hypotenuse. So I've got a 30 degrees here, my opposite is 1, and my hypotenuse is 2. So that's going to be opposite over hypotenuse. And if you want, I can go ahead and label these sides for you with 30. You can see that that's your opposite and that's your hypotenuse. All right, next thing is let's go ahead and do sine of 45. Well, sine of 45, now we have to go over here. Sine of 45 is opposite over hypotenuse, and in this case, we're going to have 1 divided by root 2. Well, what is 1 divided by root 2? Let's go ahead and rationalize it. 1 divided by the square root of 2 is root 2 times root 2. That gives me a root 2 over square root of 4, which is 2. So I'm going to go ahead and erase this 1 over root 2, and I'm going to write root 2. Root 2 over 2. All right. Next thing we're going to do is we're going to do the sine of 60 degrees, which means that we're going to go ahead and we're going to jump back to this triangle right here. So sine of 60 is going to be opposite over hypotenuse. And in this case, we've got opposite here, hypotenuse here. So that's going to be root 3 over 2. Let me go back to black. It's going to be root 3 over 2. Now you might say, Ms. Sorensen, this is taking forever, and I agree. So let's just use what we remember from filling out the trig table. And we could keep going with this if we wanted to, but we're not going to. We should know that cosine is going to be exactly the same thing, but flipped. So here we've got a root 3 over 2, a root 2 over 2, and here's a 1/2. All right, now, we know, of course, that tangent is actually equal to sine divided by cosine. So if we divided these two values right here, we would actually get root 3 over 3. Dividing root 2 over 2 divided by root 2 over 2 is, of course, 1, because we are essentially we're essentially dividing two things that are exactly the same. All right, this next one here is simply going to be root 3, and you can see that root 3 divided by 1 is root 3, 2 divided by 2 is 1. All right, I'm going to fill in the rest of this table for you. So here we've got a 2 root 3 over 3, a root 3, a 1, a square root of 2, a square root of 2, just kidding, a 1. What did I mess up on here? This one here should be a root 2. I'm sorry about that. Okay, this is going to be a 2 root 3 over 3. This is a 2, root 3 over 3. And this is a 1. All right. Now you're saying, Ms. Sorensen, how the heck did you get that? Well, we could go back through this whole entire chart and we could say, oh, cosecant is the reciprocal of sine, so that's going to be h over o. Secant is going to be the reciprocal of cosine, so that would be an h over a, and this one would be an a over o. So the same exact process, these just take a little bit of time. All right, adding 0 and 90. So we kind of did this when we look back at our unit circle, but if I draw my unit circle right here, I know I've got this point for 0, and I've got this point for 90. So just as a just as a reminder, this is the point 1, 0. This is the point 0, 1. Okay, what else we got here? We've got computer science, so a cosine, sine, cosine, sine. All right, let's throw that back in there now. So if I'm looking for the sine of 0, 0 degrees being right here, I'm going to get this one right here, which is 0. Sine of 90 is going to be 1. Cosine of 0 is this one, which is 1. And cosine of 90 is going to be this here, is 0. And hopefully we have this kind of in our brain by now, but we've got 1/2 root 2 over 2, root 2 over 2, and then we've got root 3 over 2. For cosine, go ahead and flip that direction. Root 3 over 2 is first, then we've got our root 2 over 2, then we've got 1/2. Now we need to divide across. 0 divided by 1 is going to give me 0, but 1 divided by 0 gives me undefined. Okay, so remember, tangent is sine over cosine. All right, now, I always remember this one to be root 3 over 3. How come? Well, there's 3 right here, just a reminder that that is going to be the one with the 3's. Root 2 over 2 divided by root 2 over 2 is 1. You divide both of these as well, and you simply get root 3, although I just have that one to memory. All right, moving forward. A quick review of what we've done here. If I'm talking about secant of b, I'm going to circle this, label my sides as opposite, adjacent, and hypotenuse. In this case, we've got an opposite. How come? Across from the b. Across from the 90 is my hypotenuse, and my remaining side is my adjacent. Also, as a reminder, secant is the reciprocal of cosine. Remember, cosine is a over h, so this is h over a. Cosecant, the reciprocal of sine, so this is h over o. Cotangent, the reciprocal of tangent, so this is AO. All right, going ahead, let's go ahead and plug these in. Secant b, going back to my picture, is ha, so that would be c over a. All right, next one, cosecant of b is ho, so that's going to be c over b. And lastly, cotangent of b is going to be a over o. In this case, that's going to be an a over b. Holler. Speed competition. Can you do this really quickly? I would say yes, you can. Ready, set, go. 0, 1/2, root 2 over 2, root 3 over 2, 1, 1, 0, go backwards, root 3 over 2, root 2 over 2, 1/2. 0 divided by 1 is 0. 1 divided by 0 is not possible, undefined. Oh, lots of 3's, root 3 over 3. Oh, no 3's, root 3. This divided by that, okay, is obviously going to be 1. Woo! All right, let's talk about some vocabulary for angles. So an angle of rotation is formed by rotating the terminal side and keeping the initial side in place. If the terminal side is rotated counterclockwise, then the angle rotation is positive. If the terminal side is rotated clockwise, the angle of rotation is negative. The terminal side can be rotated more than 360 degrees. Please note that 360 degrees is a full rotation and 180 degrees is a half a rotation. And of course, 90 degrees would be from one axis to another, like from the x-axis to the y-axis. All right, so let's go ahead and look here and notice that we're going up or we are going counterclockwise, which would give us a positive angle. right here. All right, now let's draw an angle with the given measure in the standard position. So here, 320 degrees, we know that's going to be less than a full circle. But more importantly, we know that it's going to go up or counterclockwise. So here's my initial side. I'm going to go a 90, a 180. Now I'm at 270, and I need to go a little bit more. So I'm at 270 here, and a 270 plus a what gives me 320. Well, that's 50 degrees. Okay, so I really should mark in here that this is 50 degrees more than when we hit this axis. So that's going to be our answer. All right, next here is negative 110 degrees. So here, I've got to go down, or I want to go clockwise to talk about a negative angle. So I'm going to go down 90, and then I've got to go a little bit more. Okay, well, I need a negative 90, and what else do I need? I need a negative 20 as well. So this here is going to be at 20 degrees. And I don't have to put the negative there because we know it's negative because it's going down. And I'm just going to go back and I'm going to add that we've got this direction here with an arrow and this direction here with an arrow. All right, next. Here, we're going way more than 360. In fact, I want to try to figure out how much more. Well, we've got 360 plus 360 is at a 720. Can I add another 360? Let's see. Nope, that gets me to 1080. So really what I'm trying to figure out is plus what is going to give me 990. Well, I've already got 720, so 990 minus 720 is going to give us what? That's going to give us 270 degrees. Okay, so if you were to re-add this up, 360 plus 360 plus 270, you do in fact get 990. All right, let's go ahead and draw this. Okay, we of course have to start here. And I'm going to go up or counterclockwise because we have a positive angle here. So I'm going to go a full 360. That takes care of that. Another 360. That takes care of that. And 270 is going to be 3 90s. So I'm going to go up a 90, another 90, and another 90. And I'm stopping here. So my initial side is here. And my terminal side is here. All right, that's it. Coterminal angles are angles in standard position with the same terminal side. So for example, angles measuring 120 and negative 240 are coterminal. So here's a picture of that. You can see that 120 leaves us with the terminal side here, but also so does negative 240. Basically, coterminal angles represent the same angle, except one might be going around the circle more times, or one might have a negative angle, but still their terminal side is exactly the same. There are an infinite many number of coterminal angles. Sometimes they'll ask you for 2, sometimes 1. Just know that they're an infinite number. All right, this next question here is asking me to find a positive angle and a negative angle that are coterminal with the given angle measurement. So I'm simply going to add 360 to this. Okay, 360 plus 65. That gives me 425 degrees. That's my answer for the positive one. Now for the negative one, I'm going to subtract 360. And that's going to give me, oops, negative 295. And that's going to be my negative answer. Now, like I said before, there's an infinite number of these, so you could keep adding 360 to the top one and keep subtracting 360 to the bottom answer if that's what you so desire. All right, the next one here, find the measure of positive and a negative. Go ahead and pause this video and try it on your own. I'm going to go ahead and do this real quickly, and you should check your answer with mine. Okay, so you should have received a positive angle, and I would have accepted 770, 50, or any other values that would have just been adding 360 to both of these. Now, the next one here, I actually had to subtract 360 twice in order to get a negative, and negative 310 works. You could subtract 360 again, but here are just a couple of examples of the correct answer. All right, now let's talk about the first quadrant, second quadrant, third quadrant, and fourth quadrant. To remember this, I like to say, remember where we live, and we live on Lake Chelan. So if I draw a C, this is going to be where my C started, is my first quadrant. Then I hit my C over here. Then I went to my third quadrant. Then I went to my fourth quadrant. That's how I remember. So looking over here, let's read this. For an angle theta in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. Okay, well, where's the x-axis? This is just review from Algebra 1. The x-axis is right here. Here, the x-axis is here. X-axis here and here. So the reference angle is from the terminal side right here to the x-axis. From the terminal side right here to the x-axis. And it doesn't matter which direction these angles are going, the arrows I mean. Same thing here, here's my terminal side, and here's this angle would be right there. Here's my terminal side, and here's my angle. Those reference angles will be really important later on. All right, that's it for our review. Now, go to the next assignment to find your video 2 after you've done your assignment for the review. Thanks so much.